graph of a function in two variables. Let's remember at first the graph of the function in one variable y equal fx. So let's take this function on the interval ab. So what is the graph of this function? It's by definition the set of all the points x fx in the plane r power 2 where x moves in the interval ab. So for example, if we take the graph of the function y equal x power 2 on R, so we can take all the points here, x power 2, because fx is x power 2. So all these points, when x moves in R, so all these points will sketch the parabola y equal x power 2. If we take, for example, x1, y will be 1, x minus 1, y will be 1, x2, y will be 4, etc. x0, y 0. We will take all the, if we take all the points x power 2, when x moves in R, so we will have a parabola. This is exactly what was in this definition. So the graph, so this function and this graph on red, this is the graph of the function f where fx equal x power 2. Now let's take the definition of the graph of a function in two variables. The graph or the surface of the function z equal fxy is by definition the set gf or s for surface of all the points x, y, fxy. So here z equal fxy. So all the points x, y, fxy where x, y moves in the domain of the function f. The domain of the function f, it's apart from r power 2. So to understand this, if we suppose that the domain of the function f is this part here, so if the point x is given here, y is given here, after taking the point xy, so the point xy in the domain here, we will take fxy, so this z is fxy. After taking the points, the z equal fxy, we will have this point here, m. The point m, xy, fxy is a point on the surface of the function f or in the graph f. So this is the point m, xy, fxy. Let's take some examples. Example number 1, the function z equals fxy equals 0. So here, if we take all the points, the graph of the function will be all the points xy 0, where xy moves in r power 2. So this is the plane of xy. So the surface of this function or the graph of this function is the plane of xy. Second example, the function z equal fxy equal 1. So here the graph will be xy 1. So here z equal 1. So xy moves in r power 2. So the graph of this function f will be all the points here. For example, if I take any point here, so I suppose this is 1. So any point in the plane passing by the origin, passing by the point here, this point is 0, 0, 1. So 0, 0, 1. So the plane here, this plane, the equation of this plane P is z equal 1. And this plane is the graph of the function fxy equal 1, because any point here, if I take any point here in this plane, the coordinate of this point will be xy, whatever xy, and 1, because z is 1. Okay. Because if I sketch this one, so here it's orthogonal. So the z of this point here is 1. Next example, the function fxy equal y. So here z equal y always. So here z equal y. The graph of the function will be all the points xy, y, xy, y. So let's sketch at first the line z equal y in the plane. So this is a line. This is a line in the plane O, Y, Z. So here O. So after sketching this line, if I take all the points x, y, y, so x any number. So let's move this line parallel to the x-axis. If we move this line parallel to the x-axis, we will have something like this. So you have a plane here. So this plane, this is the plane z equal y in R3. So if we take any points in this plane here, any point M, x is any number, because this point could move like this, but y is always equal to z. So x, y, y. Okay, because if I sketch a line like this, so this point M and the point M0, they will, the point M0, x is 0, but y, the y of M0 is the same as the y of M, and also the z of M0 the same as z of M, so 0, y, y. Okay, so the graph of my function, z equal y, is the plane sketched here in red. Next example, the graph of the function z equal fxy equal 1 minus x minus y. So the graph will be all the points x, y, and instead of z, I will write 1 minus x minus y. So we can write this as all the points x, y, z in R3, where x plus y plus z equal 1. Yes, because if I take these two terms, the left, so I will have x plus y plus z equal 1. Then I can, how to sketch all the points? I know that the equation ax plus b plus any number by plus lambda z equal d, for example, this is always plane. So it's enough to find 3 points on this plane. So let's take these points. This point A, 1, 0, 0. So the point A, if I put 1 and here 0, it's correct. So the point A exists on the graph, on S, the graph of the function, the surface of the function, F. Also, the point here, B, 0, 1, 0. So also B exists on S. And also, because if I put here 0, 1, 0, the addition is 1. And also the point C, 0, 0, 1. Also the point C exists because if I put 0, 0, 1, the addition is 1. Now, these 3 points exist on the plane, this plane, x plus y plus z equal 1. So only I will connect them now to have this plane. So this is, so now this is the surface S of my function z equal 1 minus x minus y. The last example, let's take the function z equal fxy equal squared root of 4 minus x2 minus y2. So we can write the surface of the function or the graph of the function as all the points x, y, z, where z equal to this root, then after that, if I take power 2, I must, before taking power 2, let's wait a minute. Before taking power 2, let's remember that this term always non-negative. So if I take power 2, I must suppose after taking power 2, I will have this formula here. So I must suppose that z is greater or equal 0. This is important. Okay, so the surface is these two conditions, all the points x, y, z with these two conditions together. So what's the meaning of this? This is a sphere of center 0, 0, 0 and radius 2, because here 4, the number 4 is 2 power 2. And because of this condition here, I will have a half of sphere. So the upper half of a sphere, so it's up of the OXY axis, OXY plane. Okay, so let's sketch this sphere. We sketched this sphere here. So this is the origin 0, 0. This is here, the radius here is 2. So here we have the surface of my function f is the half of this sphere z equal root of 4 minus x2 minus 1. Only the part of the sphere up above the OXY axis, OXY plane.